So this sketch is kind of how booking.com system design will look like in terms of event-driven architecture. So we have like three system key features in booking.com. So for example, as a user, I can book a hotel or accommodation. As a user, I can view all my trip service, or it shouldn't be like trip service. Like for example, it can be like my booking, um, my booking service. So as a user, I can see all of my bookings that I have booked in booking.com platform. So these are like two key services, and also when I book a system, I want to get notified from notification service. So if I have a mobile application or in browser, so I can get like notification what's going on if I booked a hotel or not. And also I want to get email from my booking. So with the system design, basically I'm focusing on these three features that I want to book my hotel or an accommodation. I can view all my bookings, I want to get notified, and I want to receive email for my booking. So the main focus of this system design is to like design these three features with the help of event-driven architecture. So just the first thing is I will just go through this design first and then explain it phase by phase. What are the pros, what are the cons, and if there is any drawback. So first feature is like a user comes to the booking.com platform and want to book a hotel. So the user, like from the UI, search a hotel. If it's a match, he then book the hotel, make the request from the UI, and then we can have like some reverse proxy and some load balancer reverse proxy. From via that, the request is landed in the booking service. Now we have this database, and we know that our data structure is kind of structured, so we can use SQL database, and so it can be like either Postgres or MySQL, that kind of thing. And also it doesn't matter, like it can be also a NoSQL, like we can use DynamoDB for fast read and write, or MongoDB, that basically also gives us some SQL like transactional thing, as well as NoSQL features. Or also for high availability, we can use Cassandra here. And so either way, we will come back to it later. So the booking service is basically got the request and made an entry to a database. This is the booking. It creates a booking ID, and this is the booking ID, and for which hotel the request has been made. So this is the hotel ID and the booking status. Now, when the service just received a request, the booking status is requested. So we have like three entries: what is the booking ID, what is the hotel ID, and what is the booking status. And after writing this in the database, the booking service publish a message. Now, as this event-driven architecture, we are completely focusing decoupling systems, and one way to do it is to use message broker. So we can have like queuing system, but with the queue system, we can use like the feature of exchange. So for example, our broker can have topic like this. The name of this topic is topic underscore booking underscore request. So in our messaging system, we can just create this topic, and when we are like publishing the message to the broker, we can specify to which topic we want to redirect our message. In this case, is the topic booking request. So the booking service published this message to the topic booking request, going into the queue, and this queue has like two subscriber. One is the my booking services, another is payment services. So when a request came and booking service just published this topic, these two services will be the consumer and will get this message, including this data from this queue. Now, my booking service will write this data to the my booking service database, and we have like booking ID, hotel ID, booking status, payment status, and if there is any details. So we know that what is a booking ID, and we hotel ID, booking status. We publish all these things inside the message. So we get this and we request it, and by default the payment status is in progress, and we don't have like any details at this very moment. At the same time, so this message is also published, and payment service subscribe to it, and payment service get this message. So for which booking, what's the booking ID for which hotel, and what's the current status of the booking, as well as we can get all the payment information from the message, like what is the user ID, or and the payment details. For example, if it's a PayPal or via a card, the payment is being done. So the card details, for example, the card ID, CVC, and expired date, the amount, those things we basically are published inside this topic booking request. So there are like pros and cons, like these are like sensitive information, and how do we process this? We will come back to this later. So payment service get this data, and payment service write this data inside the database. Of course, it has to be secured because we have this like card details information. Also, one thing we can do is basically we don't write the card details information in our database for the security purpose, and to protect data of the user, that sort of thing. And yeah, so it's a choice. Basically, we can write this data by encrypting this thing. I mean, we can write those data encrypting, and we can basically encrypt this data and write the encrypted data in the database, or we can choose not to write it, just to store it in memory. When it's done and it's done, we can just forget about it. Either way, the payment service receives this information, write this data in the database, and then try to make the payment. So till now, it was like event-driven architecture. Like one event occurred here, and that is basically a user wants to book service. We have a bunch of information, and then all of a sudden the service doesn't need to wait for any other services. So it can just publish this message, and via the queue, the two subscriber basically get this message and does their work. So basically we decouple the system and nobody's waiting for anybody. Now, when payment service just wrote this message to the database, it needs to make the payment. Now, this is kind of like not asynchronous task. It's basically like IO blocking to asynchronous task. So payment service call the payment gateway service, like it can be a third party Stripe or something, and makes the payment. So now, after making the write to the database, payment service make the call to the payment gateway and wait for the payment to be done, and then payment status came back. It can be like success or failed or something else, and then it writes the message to the database again, and with the payment status including. So by default, it can be in progress. When we get back the message, we can just write the status. So if it's success, we write success. If it's failure, we write failure. And after that, we basically publish another message to another topic in our message broker, which is topic underscore payment status. So now we know what is the status of the payment, and we publish it, including all the data we have in this queue. So when this message has been published inside this topic, so we have like 3 subscribers to this queue. One is the my booking service, notification service, and email service. Now, my booking service basically get this data and write this payment status in the database from in progress to like success or failed. And we have this notification service and email service. So here is one thing is basically so And yeah, by the way, before going to that, notification service will get this data and build a notification message body and push the notification to the user, as well as the email service. Will do the same thing and will send email to the user. Now, uh, one thing is basically how are we ensuring the fact that we don't want to spam the data inbox of the user, like don't spam the notifications, don't spam the email box. So one thing we can do is basically from this queue, and this is a subscriber, we can basically create a delivery type, which is basically at most one. So the queue will send this message to the subscriber, notification service and email service at most one. So it means that it sends the data and that's it. It doesn't wait for the acknowledgement. So the queue basically the consumer basically gets the data from the queue, and queue doesn't wait for the acknowledgement. So uh, if the service dies, like email service is dead, it doesn't send back any acknowledgement, the queue doesn't bother and never sends back the message to the email service, like the message is completely deleted from the queue. Now, uh, what are we actually achieving from this architecture, like delivery at most one, so that this email service only have this message only once, and therefore uh, if the email service is down, it's down, and if it gets receives the message, then it can construct the email and sends it back. So why Atmos 1 is good? Because, for example, we want the user, we want to send a notification and email to the user, but the thing is, if the user basically doesn't get the email, it's not the end of the earth, so nothing basically uh, impacts that much, because the email can be missed, as well as the notification service, the notification can be missed. So we are not basically spamming the user inbox, we are ensuring that the email will be delivered, but if the email service is dead or something weird is happening here, so we don't basically spam. And it's okay if the user doesn't receive the email. Why it is okay? Because we have the record here. So uh, in the UI, the user can always check what is her or his booking status, and all those data are being read from these services, which is basically fetched from this database. What are we achieving from here? Why are we basically storing this duplicated data here, here, and here? So payment service is basically a service internal to the system. Only the system can access it, and no other component like outside of the system, for example, an end user can access this payment service. Then how do user know if the payment is successful or not? We are exposing this data from this database. So this database is kind of like an aggregated database of this booking service database and payment service database. That way, when the user wants to know her or his booking status, the call doesn't need to be in the booking service. Therefore, we are basically not doing querying from this database, from the booking service database, as well as with the booking ID, making a call to the payment service, and payment service will get the data for the booking ID and then aggregate it and send it back to the user. So what we're doing is basically hitting the service, and we are not decoupling the system. We are basically, booking service has this dependency on the payment service. But the focus of this architecture is to decouple the service as much as possible and go with event-driven. Therefore, rather than making the call to the booking service and aggregating data from this database and making the call to the payment service and get the data, we are basically aggregating this to table in another service. And we can just make the call to the service, and we can just get the data and give it back to the user. And this database is always consistent in terms of this what is happening here, and this is strongly consistent, because we have to make it strongly consistent. For example, okay, I think I may be wrong. I think it doesn't necessarily have to be strongly consistent. It can be like eventual consistent, because the payment service is updated, and by this time the booking service is not updated, and the user readbacks and the payment status is still in progress. But after some time, when the message will be published, and it will write the status back. This will get back again, and the payment service will be like success or failure or whatever it is. So we are basically giving the eventual consistency here. So it doesn't necessarily have to be a strong consistent thing. So even eventual consistency is also okay with here. Like user can basically like even check after like 30 seconds or 1 minute. That's also okay, fine too. So so this is the purpose of this service, to like have another duplicated data in this database, so that we basically decoupling the system and we're completely populating this database on events. So all the services are like decoupled and no one have this dependency of one another. Now there is a gotcha. What is the catch here is basically this thing. So we are saying that we have this queue, and this queue is basically have three consumers. One is email service, and it's notification service, and another is the booking service. And for this particular use case, we are basically saying that the queue will basically push back all the data to its consumers, and we want it to be like delivery at most one. So the thing is, as this is also a subscriber of this queue, and if we configure this topic as the queue, basically the same thing, no same thing, kind of same thing, is delivery at most one. We are saying basically that my booking service will also be receiving this data at most one, but we can have that, because if this connection is failed or the service died, we want to receive this message once again. And if the acknowledgement is not given to back to this queue, we want to receive this message once again, because this is a very crucial data we need to give it back to the user. So this is the basically thing the user why the user should trust the system, because this is the data the user basically depends on, and based on that the user knows if the booking is done or not. Of course the user depends on the email and the notification, but again, if they don't get this notification or email service, it's not the end of the earth, because the user basically will be trusting this UI more than this thing. So we can have this luxury to have the delivery at most one. So what we can have is basically, rather than like one topic, we can have like two topic, and when the payment service get back the data from the payment gateway, write it back to the database, then we can basically publish these two topic in this same message in this two topic. So we can basically say that yeah, and we basically don't want this to be a subscriber of this topic. So my booking service can be a subscriber of this topic, and this is can be like delivery at least one. So we can have like at least one delivery. Okay, I'll just copy paste this whole thing. Oh no. Yeah. So yeah. So we have this data, we write it back to the database, and we publish two same message to the two different topic, and there here is also we have this queue, and we configure it to like delivery at least one. So my booking service will we are making sure that my booking service will always get the data, and it's not lost, and we configure it like at most one. So if it fails, it fails. It's not a problem, but it's a problem if we miss the data here. So are we like solved everything? No. The thing, before going to that thing, there's one more thing, is basically what are we ensuring here? So I think there was queue that's got deleted here. Yeah. So the thing is, for example, in terms of booking.com, this is a highly throughput system, and millions of users basically come to this system for booking. And of course, during the time of festival thing, people will be going crazy to book hotel and accommodations through the system. So we'll have like high throughput, and we want to scale these services horizontally, and we want to have multiple service. Now the question is, as we have queue, each of these like container or each of these instance will get the same message. The answer is no. So even if we like horizontally scale this thing, so we have like my booking service 3 instance, does this mean that all of them will be a subscriber like to this queue and to this queue? Does this mean that they will get the same data? No, because the queue knows who is the subscriber, so there is like some load balance thing going on here. So uh, and the queue will basically ensure that it only sends the one message to one particular instance. So it can be either this one or this one or this one, but for one particular message, not the three service will get back the same message. So we are ensuring that only one service, only one system is operating on that message, not everybody. So we have like this deduplication from the queue level, so we are completely fine with it. Now, the next thing is basically what about the system? Like, is it a write heavy or read heavy system? So the thing is, when the user basically just makes a call, we have like multiple write to this database, to this database, to this database, as well as we have read to this database. So why is happening? The user makes a request, we write it here, and uh, and then we publish a topic, and then this topic gets back to the my booking service. There's another one write, and my payment service gets back the data, one write. Now payment service makes the payment. We have a payment status. So now we have like sorry, now we have like two writes, and then it publish a topic, and this is the subscriber. Also, I think this should also be the subscriber, because we need to update the booking status, which is now like if the payment is completed, like payment status is successful, then we want to have like requested from success or something like that. And so we have another right here and another right here. And also the user is basically reading from the system. So we have like one read. So why is happening? Happening is those databases are like two write, and I think this database is like one read. And I think this database needs to serve like milliseconds level write and read, so we can like perform very, very fast. So we can basically organize the database in such a way that we can perform this milliseconds level read and write, so that our system can perform really, really well. Now, also, there is this big gotcha that we basically are successful to like completely decouple the system, and all of the components are like event driven. There is no like modular level dependency, but there is like a single source of failure here, which is basically our exchange, like this, and this. So so although those services doesn't have like GX dependency, it has like dependency through this message broker system. So what if like this service is completely down? What will happen? And this service is completely down, what will happen? This service is completely down, what will happen? So that way, we basically want a resilient system. So if the message broker is down, so for example, the message is published here from the publisher, but the broker is down, now what will happen? Yeah, does it mean that we have completely lost this message and we don't know what has happened to our booking, like it's completely lost? We can have that. So what we can do is basically like replicate this broker to like multiple instances. So like we have like three systems. So when one
message needs to be published, we can basically write those data in the tree of the system. Also, we can say basically like we can say that we define a write to be successful if I can write to like n-1 system or n-2 instance, then I can define that a write is successful. So say we have like 3 instances of this message broker system, we can say like if we write to the 2 other instances, in out of 3 instances the write is successful. So we publish the message and we handle it like writing this message to the 3 different instances. So and we get back this response from this write. If the write is successful here and here but not here, but we say the write is successful. So therefore, we are basically giving this resiliency and availability that even this instance is down, this instance is up, this instance is up, so we can basically get back this data. So also it comes with these complications that now these 3 of the instance have this data and the subscriber is subscribed to this topic. So who will be like pushing those data to the subscriber, like this one or this one or this one or any of this or all of them. Now having all of them is a really dangerous thing because we don't want to have this like duplicated message be pushed to the subscriber over and over again. So what we can do is basically we can give like main replica sort of thing. So for example, we can like we have one main node and we can write to other replica node, and this main node is the source of truth that will be all the subscriber can get this data from. Of course, we have to design an algorithm that if the main is down, the other instance can switch to the main role, and when the main is like up, and we can have this algorithm that who will be the next main, or if it should be again get back its main role or something like that. But yeah, so that's basically the design here. Like we have like main replica thing and primary replica thing, and primary should be the source of truth to get the data from. So that way we are basically giving the availability and resiliency here that we don't have the single source of failure. So we are basically replicating the message in different services, and we are basically getting back the message. And even one instance is dead, we can basically get back. Other instance will switch back to its role, and we will get this data back. So it's happening here, happening here, happening here. So we have this like overall availability and as well as like resiliency. So it's a very good system, I think. Yeah. And yeah, so and yeah, we have another like failure thing. So what will happen like if the payment gateway is down, or it's not like we are not getting back the data from the payment gateway? So we can have like retry policy here. So like for example, if the payment gateway is down, so we can retry after a certain interval of time. So we can basically create another queue here, and we can basically give like another worker service that can read back from the queue and try to like call it. But the thing is basically this can be a responsibility of this payment service, so we can basically do it like inside the payment service. So yeah, I mean it's a choice. We can either do it here, or we can just create another worker service and here. And this delivery atmos one is basically ensuring that the thing I mentioned, that we don't have to have like deduplication. So we don't need to like have like one deduplication thing implemented here if we like did not configure the queue to be a delivery atmos one. So we have to like ensure that we don't spam the user's notification box or email box. So we have to like can have a redis, and for each message ID, when we get this data, we can like to redis, and next time whenever a message ID comes, we can check if it's like notified or we have sent the email. If so, then we just ignore it. If not, we then write it to the Redis and send the email notification back to the user. So each service will have like Redis for the duplication purpose. And of course, we are basically leaking the memory because we are storing this data infinity in the Redis, so we can have like 72 hours or 48 hours TTL for this data. So yeah, if all should happen instantly, but it doesn't. If it doesn't, like we have like some problems, so we can have like monitoring system to Redis. Yeah, but again, this service doesn't need to be like really thing that we have to have deliver the email. So out of 1 million user, if we like drop 1,000 users, I think that's okay. But yeah, delivery atmos 1 is the basically does doing the same thing, so we basically doesn't need to explicitly design this deduplication with Redis. But yeah, it's a choice. And for now comes to the database, like all of these database needs to be like faster read and write. Now, which one should we pick? For example, we can have this Postgres or MySQL, and we can like uh, host it in our own machine, but then we have to have this headache like managing this database. Or we can use like uh, managed database, like we have like AWS gives AWS RDS. We can basically use the ready Postgres or MySQL from there, but it's not like milliseconds level read or write. We really need the milliseconds level read or write here because it's really really important that it performs very very fast. So as I said, this can be a structured database or unstructured database, but I think the focus should be if we can perform milliseconds level read and write. And I think for this DynamoDB is the perfect choice because because as you can see, all those data are less than 4 KB, and DynamoDB has this 4 kilobyte threshold for a read and write, and it fits perfectly well. And DynamoDB gives the milliseconds level read and write, so it's the perfect way if these are your lambdas or if these are your containers like inside Kubernetes, so you can basically hook it in with your AWS environment with DynamoDB, and it gives you like milliseconds level read and write. So it's really really well. Now, in terms of message broker, which one should we use? So we have like choice. We can either go for Kafka or we can go for RabbitMQ. Also for like serverless thing, we can have this combination of SNS and SQS. So the thing is, this needs to be very very fast and reliable, and availability should be high, right? So we can like have our own Kafka cluster and implement all those things that's already built in Kafka, like this replication thing. Or we can also have RabbitMQ, but the drawback is we have to like host these services, as there is no like managed services at this moment. Although I think there is like managed services at this moment for RabbitMQ and Kafka, but I think uh, I don't know. I basically am not sure how they perform well also, but I think this combination like SNS SQS is really really well in terms of compared to the Kafka and RabbitMQ. They are like the services of Amazon AWS. So basically, what is SNS? SNS is basically topic, and this, I mean, in RabbitMQ, this whole thing comes as exchange. You can call it message broker. Same for Kafka, but in AWS, this is like two different instances. So this topic is basically the SNS, and this queue is basically the queue SQS, and we can bind these two, and we have this like same broker as we get by default from Kafka and RabbitMQ. And this is like already hosted in AWS, so you don't have to like think about how to scale in, scale down thing. And this is really in terms of availability and the resiliency, AWS gives very state-of-the-art features, so they are really really well. So you can have like 99% of the probability that your message will be passed through. It will not fail. So with this combination, you can like perform. This system can like perform really really well. So we have this SNS SQS as a exchange or message broker, or Kafka RabbitMQ, whichever is the choice. We have like database like DynamoDB can be very very well, and of course this needs to be